Hello, I'm John Chamberlain. This is the Fundamentals of Light and Lasers, Course 1. Today we're going to look at Laboratory 1-4C, the Law of Reflection. Okay, let's look at the equipment we're using today. This is very similar to what we used last lab, so it should be familiar. We've got the laser set up on lab jacks, and we've got the beam set up horizontally still with our rotating stage on our mirror. And we're going to change the angle of that mirror so that it reflects over this direction onto a screen that we've got mounted on the wall here. Alright, we've got the mirror reflecting the laser beam right back into the laser, so we know we've got it set up at 0 degrees. First thing we need to do is measure the distance from the mirror to our target surface. So Derek is going to help me. And what do you got there, Derek?
162.2 centimeters.
162.2 centimeters is our distance from the screen. And now we need to identify where that beam is at striking the wall right here. So Derek can tip the mirror up vertically. And there we see the beam just coming into view right there. So that is going to be our 0 point. And we're going to be measuring our deflections this direction as we rotate our angle of our mirror. Now let's rotate our mirror assembly by a few small increments. Let's start off by, for example, rotating it about 4 degrees. Our stage is calibrated in 2-degree increments. So we'll go 2 increments. And sure enough, we see on our screen that the beam has moved over. So I will go over there and we'll mark the new location. And there's, label that as 4 degrees. And we'll go over to 8 degrees. Mark this one as 8 degrees. We'll go another 4 degrees. We'll go up to 12. And we'll get up to 16. Alright, we've got 4 readings. That should be enough. And now we can measure our displacements from our 0 spot. For the 4-degree measurement, I see 21.4 centimeters. For our 8 degrees, I'm measuring 45.2 centimeters, measuring 69.0. And lastly, at 16 degrees, measuring 96.7 centimeters. All right, let's look through some of the calculations for this data that we've measured. If we have a y of 21.4 and an x of 162.2, we can calculate the angle by the inverse tangent of y divided by x, and plug that into your calculator and you'll get a measured angle of 7.5 degrees. And the expected angle for this would be twice the angle of rotation, so that would be 8 degrees. And if we calculate the expected difference between 8 degrees and 7.5 degrees, you'll get about 6% difference, which is not too bad. That's pretty good. If you have a 45.2 centimeters for 8 degrees, that comes out to a calculation of 15.6 degrees, which we expected to be 16 degrees. That's pretty good agreement, don't you think? And that is about 3% difference. So all in all, we did pretty good in verifying the law of reflection. And that concludes Laboratory 1-4C, the law of reflection. And we'll see you next time for the continuation of fundamentals of light and laser.